Imagine a bustling city inside our bodies, neurons firing away, constantly communicating to keep us alive, alert, and functioning smoothly. Today, let's take a lighthearted journey through some fascinating processes that keep us on our toes or sometimes make us freeze in place. Picture this: when faced with a sudden threat, like seeing a snarling dog or hearing a large noise, our body's fight or flight response kicks in. This is our acute stress response, a rapid, energizing rush that unleashes catecholamines. Think of them as tiny messengers like adrenaline and noradrenaline that flood the bloodstream. These neurotransmitters are like emergency workers relying on our neurons to respond swiftly. Now, as these catecholamines surge, they influence neurons by activating calcium ions, tiny charged particles that are crucial for neural communication. When calcium conductance increases, neurons become more excitable, ready to send signals quickly. This heightened activity is part of what we call neurochemical arousal, making us alert and ready to act. But hold on, there's more happening beneath the surface. The respiratory system plays a key role here. During a panic or intense stress, many people hyperventilate or hyperventilate, altering the levels of carbon dioxide in their blood, state known as hypocapnia when carbon dioxide drops too low. This imbalance affects the intracellular pH, the acidity or alkalinity inside our cells, leading to a state called alkalosis, where the environment becomes more basic. Intracellular alkalosis can influence neuronal responsiveness, often making neurons less reactive or more excitable depending on the context. For instance, in hyperaroused states, think of a human in full-on panic. This shift can contribute to symptoms like dizziness, tingling, or even feelings of depersonalization. It's like the brain's internal chemistry is throwing a little party, but sometimes it gets a little bit out of hand. Interesting, our body's response isn't just straightforward fight or flight. It can be biphasic, meaning it has two phases. Initially, there's a burst of sympathetic activity with high catecholamine levels, followed by a possible phase of hyperarousal where the body temporarily shuts down to protect itself. Now let's zoom into the neurons themselves. They're tiny but mighty, maintaining a resting membrane potential voltage difference across the membranes, thanks to ions like potassium, sodium, and calcium, moving via specialized transporters, including sodium-calcium exchangers and cotransporters. These electrolytes move to keep the neurons ready to fire again and again. All these systems respiratory control via the bulbotin respiratory network, receptors detecting carbon dioxide and pH levels, cortical and limbic areas processing fear and stress, are constantly communicating. They maintain the delicate balance of our internal environment, the milieu interior, keeping us stable amidst chaos. So next time you feel a sudden rush of adrenaline or find yourself frozen in place during a stressful moment, remember it's all part of an intricate, beautifully coordinated little chaos that makes being human so fascinating. Our internal world is as dynamic and unpredictable as any adventure out there.